Hello guys, welcome to this new video. Today we're gonna continue with Linux kernel module development, and we're gonna go for the third example. And maybe this video is gonna be a bit shorter, but I'm not exactly sure about it. So let's go on, and without further ado, let's start. So the init and exit macros. The init macro causes the init function to be discarded and its memory freed once the init function finishes for built-in drivers, but not loadable modules. If you think about when the init function is invoked, this makes perfect sense. So the init macro causes the init function to be discarded and its memory freed once the init function finishes for built-in drivers, but not loadable modules. Okay. There is also an init data, which works similarly to init, but for init variables rather than functions. Okay. The exit macro causes the omission of the function when the module is built into the kernel, and like init, has no effect for loadable modules. Again, if you consider when the cleanup functions runs, this makes complete sense. Built-in drivers do not need a cleanup function, while loadable modules do. Well, I am a bit confused, honestly. Also, this code is pretty much, I think, the same as the one in LO2, if I'm not wrong. Let's make clean. Now it's clean. So yeah, we have the init here and the exit. Those are macros. Okay. I'm still not exactly sure how a macro works. So the guy is just saying that the init macro causes the init function to be discarded and its memory freed once the init function finishes for built-in drivers, but not loadable modules. Okay. So when this function gets called, if it is a built-in module, the memory, I guess, of these functions get discarded. But if it's an external module, it does not. If this is what I got. And the exit macro causes the omission of the function when the module is built into the kernel. And like init, has no effect for loadable modules. Oh my gosh. No, I did not. I definitely didn't understand this. So let me try with ChatGPT. Like, what does init and exit? Yes, exit do in functions in C. Are macros often used in the Linux kernel to mark specific sections of code, particularly for initialization and cleanup functions. They help optimize memory usage as they tell the the compiler to place these functions in specific memory sections that can be freed or handled differently. So for example, for init, this macro is applied to initialization functions that are only needed during the module or driver loading phase. Functions marked with init are stored in a special memory section that can be freed after initialization. Once initialization is complete, the memory occupied by init functions can be released to free up memory, which is especially useful in embedded systems. But isn't this always the case, like with standard functions, that when they go out of scope, I guess, like variables here, if they are used, they go out of scope, aren't they already, if they are not heap allocated, go out of scope? I mean, they don't get deallocated by default. Let's see, the exit macro is used for cleanup functions that are only required when unloading a module, if the module is compiled as a loadable module. When applied to functions, it ensures the function is included in the compiled code only if the code is compiled as a loadable module. If the module is statically compiled into the kernel, the exit functions may be discarded to save memory. Static int init my module init my module exit. My module init is marked with init, so after the module loads, its memory can be freed. My module exit is marked with exit, meaning it will only be included if the module can be unloaded. But isn't it always the case that when a function has completed its execution, its allocated memory gets released by default? Oh my gosh, I don't know why. Okay. You're absolutely right. In general, memory allocated on the stack for a function call is released when the function completes. However, init and exit serve a different purpose because they are related to the way the Linux kernel handles memory sections for code, rather than temporary stack memory used during function execution. In a typical program, once a function finishes executing, any stack memory it used is indeed freed automatically. Okay, this is what I was referring about. When we talk about init and exit, we are actually talking about entire code sections in memory, not just stack or temporary data. Here's how this applies. Kernel module and static sections. When you load a kernel module or initialize a device driver, wait, did he use static? Yes, he did. When you load a kernel module or initialize a device driver, all the code, including its functions, resides in memory for as long as the module is loaded. This includes initialization code, even though it may only be used once. By marking functions with init, the kernel can specifically place these functions in a section of memory designated for initialization. Once the module is fully loaded, the kernel can then free up the memory used by the initialization code, which wouldn't happen by default. Okay. Similarly, functions marked with exit are only retained in memory if the module is compiled to support unloading dynamic modules. In cases where the module is statically compiled into the kernel, like the built-in modules, I guess, exit marked code can be discarded as it will never be called. Why this matter? Memory efficiency. In the Linux kernel, especially in embedded system or constrained environments, saving memory is crucial. Every bit of unused code should ideally be freed when not needed, which isn't something a typical C program requires. Static versus dynamic memory. The memory where code sections are stored is managed differently in kernel space than user space applications, where it's often dynamically allocated on the heap or stack. Kernel code has fixed sections, so freeing memory means moving entire code segments out of RAM. In summary, init and exit enable a kernel module code to be placed in specific sections that can be freed once initialization completes or if unloading isn't supported. This memory management is specific to how kernel modules handled and helps optimize the use of limited memory resources. Let me ask another question. And what is the keyword static used for? Since I've seen use static for in a lot of programs, but I did not fully understand like the real meaning of it. Static keyword in C is versatile as it affects the visibility, lifetime, and linkage of variables and functions, depending on where and how it's used. Here's a breakdown of its main purposes. File scope. When static is used with a global variable or function outside of any function, it restricts its scope to the current file. This is called internal linkage. Without static, global variables and functions have external linkage by default, meaning they can be accessed from other files. Marking them as static hides them from other files, making them accessible only within the file where they are defined. So it's a way to hide certain functions and variables, basically. Static int count equals 0. This variable is only accessible within file1.c. Static void helper. So like in this case, I guess. So this function is only accessible within file1.c function code. Here, count and helper cannot be accessed directly by other files. If another file tries to use count or call helper, it will result in an error. Okay. When static is used with a variable inside a function, it changes the variable's lifetime from automatic to static. Automatic? Unlike regular local variables, which are reinitialized every time the function is called, a static local variable retains its values across multiple calls. So the lifetime is increased in this case, yes. Now this I knew, it was the only one I knew. So yeah, if you declare a variable as static and it's inside a function, it just means that you extended the lifetime of the variable. Cool. In a struct, C does not allow static variables inside the struct definition. Okay. Okay, got it. So this just basically hides the content of this function. So let me add a bit of documentation for these functions. The the init macro declares these, or maybe more than declare, we can say that signal this function as being I don't know, let's say the init macro signals that this function is from a module, a kernel, an external kernel module, and the memory allocated by itself can be read after the function as returned. Okay, and right, for this instead, the exit macro signals that this function I forgot. It's used for cleanup functions that are only required when unloading a module. Okay. The exit marker signals, let's say, ensures that the function is included in the compiled code only if the code is compiled as a loadable module. Okay, understood. Nice. Let's move on. So yeah, I got all of this, but wait a second, wait a second. Let me open it again. Did we include? Yes, we included any.h. Okay, so in this hello tree is just adding this static int hello tree data. What? Any data? What? There's also an init data which works similar to init, but for init variables rather than functions. Okay, makes sense. I will not create another file just to write this because it's very similar. What happened? Okay. Honestly, who loads or even cares about proprietary modules? If you do, then you might have seen something like this. You can use a few macros to indicate the license for your module. Some examples are GPL, GPLv2, GPL and additional rights, dual BSD, blah blah blah. To reference what license you're using, a macro is available called module license, which we already used. These and a few other macros are describing the modules. The modules are listed in below example. Okay. So module license, module author, module description. Cool. Okay, let's go to the fifth example, and just to stick with the book, I will call this directory lo5. No. And here modules can take command line arguments, but not with the argc, argv you might be used to. To allow arguments to be passed to your module, declare the variables that they will take the value of the command line arguments as global, and then use the module param macro defined in include linux module param.h to set up the mechanism up At runtime, intsmod will fill the variables with any command line arguments that are given, like intsmod mymodule.ko my variable equal 5. And you have to explicitly write the variable. The variable declarations and macros should be placed at the beginning of the module for clarity. Okay. The example code should clear up my admittedly lousy explanation. The module parameter macro takes 3 arguments: the name of the variable, its type, and permissions for the corresponding file in sysfs. Name, type, and permission. What do you mean permission? Integer types can be signed as usual or unsigned. If you'd like to use arrays of integers or strings, see module parameter array and module parameter string. Arrays are supported too, but things are a bit now than they were in the olden days. So this module parameter takes 3 arguments: name, type, and permission. I didn't see this permission thing. So it does have a file in sysfs. What is sysfs? Wait, let me put English. Oh, there's no English here. Okay, we have it in the Italian one. It's a pseudo file system provided by the Linux kernel that exports information about various kernel subsystems, hardware devices, and associated device drivers from the kernel device module to user space through virtual files. In addition to providing information about various devices and kernel subsystems, exported virtual files are also used for their configuration. Let me see here, please. No. Yeah, here. sysfs is a RAM-based file system initially based on RAMFS. It provides a means to export kernel data structures, their attributes, and the linkages between them to user space. sysfs is tied inherently to the kobject infrastructure. Please read documentation kobject.txt for more information concerning the kobject interface. sysfs is always compiled in if config sysfs is defined. Okay, for every kobject that is registered with the system, a directory is created for it in sysfs. So if I'm a bit scared, if I mount this, it's gonna be going in sys mount file system. Let's just do it. Let's fucking do it. Oh, right. So now if I go to sys, yeah, sorry. Yeah. For every kobject that is registered with the system, a directory is created for it in sysfs. Did we read only? Yes. That directory is created as a subdirectory of the k-object parent, expressing internal object hierarchies to user space. So in this case, if I mount a new kernel module, it's gonna create a k-object directory in sysfs. The directory is created as a subdirectory of the k-object's parent, expressing internal object hierarchies to user space. Top-level directories in sysfs represent the common ancestors of object hierarchies. Okay. Sysfs internally stores a pointer to the k-object that implements a directory in the kernfs node object associated with the directory. In the past, this k-object pointer has been used by sysfs to do reference counting directly on the object whenever the file is opened or closed. Doing these things gonna get you probably so humiliated and your code written without notice. So let me see, if I go like for example here, sorry, I don't know. But I don't see this k objects directories. I don't know. Let me see, let me go for a second here. No. Or maybe USB? No, there's nothing in there. I don't know. I guess maybe it's gonna be in the book, so we'll see. So arrays are supported too, but things are a bit different now than they were in the olden days. To keep track of the number of parameters, you need to pass a pointer to account. To keep track of the number of parameters, you need to pass a pointer to a count variable as third parameter at your option. You could also ignore the count and pass null instead. We show both possibilities here. So here, not interested in count. This is the pointer to the array type. This thing, which is like the pointer to a count parameter, and the permission. Okay. A good use for this is to have the module variable default values set. Like a port or IO address. If the variable contains default values, then perform auto detection. Otherwise, keep the current value. Lastly, there is a macro function, module parm des, that is used to document arguments that the module can take. It takes two parameters, a variable name and a free form string describing that variable. Okay, let's try then this new module. Plugin updates. Yes, I'm gonna do it later. So, oh no, sorry. Why is it this broken? Ah, yeah. Okay. Okay, so let's add the license. GPL. Then we have some static variables. So static short int my short equals 1, which I guess these are like the parameters that are going to be passed to the module, and these are the default values. Yeah, I will write this. Parameters to be passed to the module with their default values. Short int my short equals 1, static int my int equals 420, static long int my long equals 9999, static char, this is an array, my string equals blah, static int my int array equals 420 yeah, static int rgc equals 0. I don't know what's that. Okay, then we have this module parameter. I'll just copy all of this. Why did it put all these spaces? Okay. So module parameter, the first parameter is the parameter name. Second is data type. Final argument is the permission bits. For exposing parameters in sysfs if non-zero at a later stage. What? Okay, I didn't understand the last point, but okay, let's move on. So, module parameter. One is my short. It's of type short. What's going on? Why don't I have the syntax highlighted? And but that's, oh my gosh, what's all this? Let's just copy it for now. That's a bit awkward. We also make the interface a bit bigger. Then we have the macro par description, which is just a description. Probably it's gonna be in the, how is it called, the fuck, the log. I don't remember what was the name, but anyway, module parameter. We have my int of type int, and then the same, no, not exactly the same, everything except the last, oh no, except this last one, which is that is IROTH. Okay, then we have the description. Of my int, which is an integer. And then we okay, I'm just gonna copy all of this because it's pretty boring and I understood. Yes, I don't understand why I get these spaces, but anyway. And then we have the module parameter array, which does exactly the same thing, but for arrays. Let's cut here this one. Okay. No. Okay. Nice. Okay. And then we can have the int function. hello5 init, which takes byte and returns an int, which I forgot. Okay. See how it is to make errors in C, and then you compile and you don't know what the fuck is going on. So let's print some debugs info. Hello world, and okay, I would not do what he did. And then okay, let's put a slash on. Oh. And yes, my short, oh my gosh, wait, my short is a short int, and then input is age HD. What does HD do? Is it for short integer? I guess. And then my short here. And then we have my int is an integer. And then this slash n. Then we have my int. And then my long is a long integer. Long integer. My long. And then I just copy all of these because it's all the same. Let's put some indentation. Here. Okay. And let's just copy also all of this because I got tired of writing. Yes. And let's remove some spaces. So here also we need to put some indentation. Wait, I remember how to do it. Yes, like this. Yes. Nice. Nice. Oh no, what happened? Undo. Okay. Nice. Now let's save. I guess I need the make file now. So yeah, let's just copy the make file from the previous ones. Nice. Let's see if everything is okay. And no, the object is number 5. So now if I do make all, no, we had some problems. Expected comma or semicolon in here, line 22. Let me see. Yes, here. Oh wait, yes. Okay. Okay. By the way, I need to enable the lines in Vim. And numbers Vim in new Vim. Set number. Wait, let's do it here. No, I don't have this init.vim. Okay, yeah, this one. Yes, it works. Nice. Let's go back here. Let's go back to programming, kernel experiments, hello 5, and let's make all. Nice. So we have everything. So now let's try this. Sudo. Wait. Now let me make this small again. Okay. Sudo insert module. Where is it? Where is it? What happened? Okay. No. Insert module hello5.ku. My string equals pvv and my so we can also not give every variable. Nice. So now if we print the logs, my short is short into my int is an integer. Nice. Nice. So nice here. I just have a few questions. Oh yeah. Makes sense. Make absolutely sense. I'm just confused about this. Got one argument for my int array. Where did it take it? Where did it take it? Here. RRC. Which is yes, here, which is the count, and we declare this count as 0. So the count is updated by itself by this function. Okay, cool. Then let's remove the module. Remove module -5. Sorry, what am I doing? Yes. So now if I print again, goodbye word 5. Nice. No, I don't want to do it right now. Okay. Nice. So I guess this is gonna be it for now, because I need to go. My alarm is about to ring. Yeah, I had a lot of fun. Today we learned about static, about init and exit macros, and about how to pass arguments to kernel modules, which is pretty cool. So I hope you enjoyed. See you in the next kernel module development video. Bye bye.